Hi everyone, welcome to the first episode of the Open Source Observability Podcast. We'll be learning about different technologies in the open source observability space and getting to talk with developers to learn what kind of projects they're working on and what you might want to adopt at your organization or integrate into your observability toolset. I'm your host, Alex Lamberton, and I've been working with open source for about 6 years now and have been using Linux since I was a kid. Open source philosophically is very important to me so that innovation is possible to everyone all over the world and that technology can grow anywhere without any barriers to entry. So some of the questions you're going to hear would be great if you're a student, you're a new DevOps engineer, you're a new site reliability engineer, or you're a company considering, hey, do we want to integrate Kafka or Altinity or Coroot for the first time? And so I hope that you enjoy and you get to learn a little bit today. Without further ado, let's start. Welcome to the first episode of the Open Source Observability Podcast. Today we're here with our guest, Josh Lee, who is a developer advocate at Altinity. And so for any listeners that haven't had the pleasure to listen to some of your talks, Josh, can you share a bit about your background and what you do to support developer advocacy?
Sure. So I have a background in engineering and then as a product manager at an observability platform. Um, and observability is really one of the main use cases that we see with Clickhouse, which is the database product that we offer hosting and support for. And I should specify that we're not affiliated with Clickhouse Incorporated. We're a separate entity, but we are open source contributors. And so, yeah, like I was saying, observability is really one of the main use cases that we're seeing there. And so with my background, right, it's just about creating content and educational tools around how to use Clickhouse for observability. And then a lot of that also involves advocating for observability tools like OpenTelemetry.
And so things like OpenTelemetry and some of the things like Clickhouse, these are open source tools. So can you tell our audience a bit about how you became involved in the open source community and why it's important to you?
Sure. So open source has always been important to me. I started my career as a contractor, building projects, for small to medium-sized businesses and startups. And even then, right, I tried to build as much as I could on top of open source. I have philosophical leanings that make me like open source, but I also think that there are really practical reasons to choose it, whatever your philosophical or ethical feelings are towards open source. The main one for me is the flexibility, right? And our CEO Robert loves to say this too, right? Like it's just awesome when you can take something and pick it apart and see how it works. And I have the kind of brain where like that's really, really appealing to me. So open source has always been really appealing because you can take it apart and see how it works. And in many cases, even find the people who made it and ask them questions. And they're going to be really welcoming and just happy to have some excitement for their project, and they're going to want to share with you. So for those reasons, I love open source, but there are many more.
Yeah, I've heard those are all like really great reasons. There's the philosophical, which we won't dive too into. If our listeners are FOSS, then they'll know. I've also heard that argument that instead of dealing with a huge vendor, you can just go message someone and be like, hey, like you built this, how do I fix this? Or for anyone that actually really wants to see how it works, they can get into the code and modify a bit about themselves. So you get a really exciting community where there's an openness to innovation. So I feel the same
Yeah,
way.
I just wanted to add to that. Sustainability is really important to me too, right? And so open source gives you that guarantee of longevity, right? And that you can take over supporting something for yourself. And that's something that I've been hearing a lot, right? Like when we kind of talk about some of these like license changes in the FOSS world, and like, is it truly FOSS if we're limiting what people can do with it and things like that? Something that I've come to appreciate is the model where maybe companies get to keep something to themselves for a short period of time, but then eventually it becomes open, right? And that gives anyone adopting it that guarantee that they will eventually have ownership of it if they need to, and they won't be abandoned.
Yeah, that's
Anyways,
great. The idea of, like you said, I think the word you used was sustainability, and that doesn't necessarily just mean environmentally, but in terms of the software. Actually, say if companies come and go, that there's not vendor locked in, maybe refers to something more short term, but that people can use the software afterwards and continue to grow with it and benefit from it. So I think that's another really great reason.
yeah, absolutely.
So I listened to your FOSDEM talk, and for our listeners, it was really great. I'm going to link it in the description as OLI, which is short for Observability in One, which is exploring a unified telemetry database. And Josh talks a little bit about how Clickhouse is the perfect database for observability. So Josh, could you summarize for maybe new site reliability engineers or tech adjacent people what Clickhouse is and why it's the perfect database for observability?
Sure. So ClickHouse is first and foremost, it's a columnar database. It's what we would call an OLAP or OLAP database versus an OLTP database, not to be confused with OTLP when we're talking about observability. But an OLTP database like OLTP, like Postgres, would be a transactional database. And one of the main characteristics of transactional databases is that they record the data in rows, which is really great when you want to know all of the information about an individual transaction, who the transaction was for, what the items were in it, in the case of an order, for example, right? And maybe any values associated with that. But if you're trying to do math across all of your transactions to calculate, for example, how much money did we make this month, or how many of our requests had a 400 error in them, you're trying to aggregate across a single column across, in some cases, billions of rows. And so in a traditional row-oriented database, you have to read the entire row just to get that single value that you need out of each one. Whereas Clickhouse, as a columnar database, is actually storing the data by column, which means that it can really, really quickly just read one part of the disk that has all of the data for that column for every single row, and you can get your answers back really, really fast. So that's sort of the main differentiator between Clickhouse and databases that listeners might be more familiar with. There's a lot of other stuff going on, right? Like if there's a way to make a database go faster, you're going to find it somewhere under the hood of Clickhouse. And what that means for observability, right? Observability generates a huge amount of data. In some cases, I've seen your observability data compared to your actual real data that is your transactional data, you might have 30 to 50 times more observability data than your transactional user data. So that's a ton of data that you have to deal with. You have to store it, ideally very quickly, because you also want to be able to query it almost immediately, right? If you're running alerting, your alerting pipeline is going to have latency based on how quickly you can record all of that data and then query it and detect anomalies in it. So if you want to be able to do that on the order of seconds, then you need a database that can ingest the data in milliseconds and respond to queries in seconds. And Clickhouse can do that. And another great advantage of it for observability that I love is that it's not limited in cardinality. So some observability databases, the way that they store the data is they're kind of like multiplying your data by the amount of cardinality that you have in a specific column. And that can lead to like a storage explosion. Clickhouse, if you're smart about it and you keep your cardinality out of certain places, there are places where you can put it where it can be practically infinite and you just don't even have to worry about it.
Oh, okay. So that's a really great description because I've heard those terms before, whether it's a row-based database or a column one. So if I understood that correctly, ClickHouse focuses on that column analysis, which is much, much faster if you have to go across the entire map, which makes it perfect for observability because you're dealing with sometimes huge quantities of data and you don't want latency issues, obviously. So that's why it makes it really ideal. Could you describe quickly what high cardinality is for anyone that might be new to the field or is trying to understand a bit more about observability?
Sure. So we have, when we're talking about data sets, right, we have dimensionality and cardinality. So dimensionality is the total number of fields that you would have on a data set, right? So if I say I have a model for a person, their name would be a field, their birth date would be a field. Each one of those is a different dimension, right? And then cardinality is the total number of possible values within a specific dimension. So for name, that's going to be very, very high cardinality, right? Because there's a wide range of human names. Whereas if I have a field that's like an address and has a state, if we're talking about US states, right, that's capped at a cardinality of 50 because there are only 50 possible values.
So high dimensionality is how many categories there are, and high cardinality is how much variety within that category, if that makes sense.
Yes,
Perfect.
yeah, that's a
Okay,
good way of
cool.
putting it.
That's a great description. So in your talk, you also talked about eBPF, Kafka, and FluentD as some of your favorite sources of telemetry data. Can you describe maybe why you like those the best and how they fit into an observability stack?
Sure, absolutely. So I think the best observability is observability that you can actually get started with, right, as quickly as possible, right? The sooner you can show value from your observability, the easier of a time you're going to have building adoption, especially within a large organization. So those are three tools that I listed specifically because depending on the type of organization that you're at, they might provide a very quick on-ramp to good observability. In the case of eBPF, it's an awesome tool that we can probably dive into a little bit more. That when you use eBPF powered agents, you can kind of get like out of the box, like no code batteries included observability, which is really, really awesome if you don't have anything yet. Kafka is something that would be a very specific use case, but it's a specific use case where if you're at that scale, it becomes powerful. So there are some organizations where they might already be heavy users of Kafka and already have a way to get their observability data into Kafka, and then that becomes a very convenient pipeline for getting it to an observability backend. And then FluentD, I'm a big fan of using what you already have. FluentD is very popular, very common. Agent, if you're using that or similar agents, right? Like we use Vector internally at Altinity. If you're using one of these agents, there's not a lot of reason to switch because the beauty of the OpenTelemetry ecosystem is that it's so compatible with everything. And so you can just keep using what you're already using and put an OpenTelemetry pipeline behind it and then slowly migrate as as you need.
So yeah, OTEL fits really nicely into all of these. It sounds with FluentD, that's common, and then it's compatible with everything, which is great. Kafka has certain use cases, and eBPF kind of helps with the zero instrumentation stuff where it like populates everything. And going back to open source kind of being at the heart of Altinity, can you tell us a little bit about some of the open source projects? I see there's a lot of Clickhouse stuff that you guys contribute to and maybe maintain. Is there a favorite project that you like or would like to share?
So probably our most popular project is the operator, the Clickhouse operator for Kubernetes, which is the easiest way to run Clickhouse in Kubernetes. Running databases on Kubernetes can be a little bit scary. I was certainly apprehensive when I first heard of the idea. But the operator makes it really, really easy and takes a lot of the pain out of things like rolling upgrades and managing persistent volume claims and making sure that you don't accidentally delete your data and all of these things. So the operator has been downloaded over 100 million times. It's how we run our own cloud. And yeah, it's the best way to run ClickHouse on Kubernetes. We also have ClickHouse Backup, which is an extremely popular utility that we maintain. Does what the name says on the tin, great utility for backing up ClickHouse. And we maintain a plugin for Grafana, a Grafana data source plugin for ClickHouse that has some really nice features for doing things like translating things into the types of time series that Grafana expects when we're trying to create graphs and visualizations. But probably my favorite project would have to be our new open source extension of ClickHouse, which we're calling Project Antalya for now. It's sort of running a little bit ahead of upstream, and what we've added is some capabilities to make ClickHouse more deeply integrated with data lakes, specifically Iceberg and Parquet on S3 compatible object storage. So this is, to me, extremely exciting because as we were talking about, right, with observability, these data set sizes are growing exponentially, and the observability ones are already multiples of the core data set sizes that are growing exponentially. And the problem is only being compounded by things like LLMs and AI that are not only generating a lot of data, but also generating huge amounts of monitoring data and observability data. So the idea that you could then have all of the power and speed of ClickHouse backed with the infinite scalability of something like S3, which is like the eighth wonder of the world, right? That to me is just awesome. And the fact that it's totally open source, so you can run it on your laptop and play with MinIO if you want, and then scale that up to all the way to enterprise running on 64 core nodes on EKS. It's awesome.
Can you break down what a data lake is, and then tell us what you called the eighth wonder of the world? I think it was S3.
Yeah, so S3 is Amazon's object storage, right? And I call it the eighth wonder of the world just because it's kind of it completely changed the way we think about storage, right? Like this idea that you could have just one place where you put something and the durability is so high, right? Like I think Amazon has something like 9 nines of durability. So the odds of you actually losing data off of S3 are so infinitesimally small that we've all sort of just decided, okay, we can just trust this thing. It's never going to go away. Maybe that's maybe we're mistaken to do that, but so far it's been working out. And it goes down sometime, right? Like various parts of AWS will go down sometimes. But as far as I know, nobody's lost any significant amounts of data off of S3 that was important to them. So that's just really impressive in its own right. And then the scale of it is mind-bogglingly impressive. But what that means is you can throw petabytes and petabytes of data at it, and right, that is then stored in a single place. And so this is really the power of Project Antalya, is that you then are empowered to, with traditional ClickHouse, to have high availability of your data, you would need at least 3 copies of it, right? 3 replicas. And that way you can ensure that even if one node goes down, there are another 2 nodes to have quorum and agree on what that data should look like, essentially. With S3, you're sort of offloading that replication, and you're making it Amazon's problem. and it's completely opaque to you, right? And you have one copy of your data that is then accessible by everything. And then once you have one copy of your data that's accessible by everything, that then means you can independently scale your compute. So you can say, hey, I have this really difficult query, or I have a time with a very high workload, a lot of users are logging in, running a lot of queries, and I need to be able to respond faster. So I can just scale up a bunch of compute-only nodes that all have access to that same copy of the data and all can talk to each other and communicate and coordinate and sort of swarm that data set and respond to queries really, really fast. And then when I don't need them anymore, I delete them and I stop paying for them, and I don't have to think about them.
Oh, it's really easy, opt-in, opt-out. Interesting. So yeah, you can connect the node. Everything can talk to this data set that's stored in, I think it's S3 is Amazon's thing. And then you can just scale things really easily. And then when it's done, it goes away and the data doesn't disappear. Interesting.
Yes.
And then can you tell us what a data lake is? And a little bit about Iceberg, because these are all connected to, is Talia the name of the new project that you were describing?
Antalya. So it's named after the city in Turkey where we had our first meeting to sort of plan the project.
Oh, that's exciting. Okay, cool. It's a nice name.
Yes. Yes. So a data lake, what is a data lake? So we have to go back in time a bit and start with what is a data warehouse, right? So we're starting with this idea of a data warehouse, which is kind of came about in the 80s, and the idea was that you would take all of your relevant data, right, from across your organization and sort of feed it into this pipeline where you're transforming it into very specific structured schemas so that you could run reports on it and answer questions. And maybe you would be like getting your data and like you would be getting all of your data set from your various systems, transforming it into the specific format needed by your data warehouse, maybe on a nightly basis, right? So we're talking about batch processing. And then that data is going into the data warehouse in this structured format, which then allows you to read it really, really quickly and generate reports and graphs and do interesting things with that data, right? But the limitation here is that you have to get everything into the correct format first in order to then have that benefit of that speed and performance on the query side. Data lakes were sort of this idea that came about where it was like, well, let's not worry about putting everything into the correct format to begin with. Let's just throw everything into some storage somewhere, right? Really only made possible because of the existence of S3 and now it's compatible with competitors. We just throw everything into one giant lake and then sort of have different things reading that and maybe transforming it after the fact into the formats that we need and loading it into various data warehouses for reports. So this sort of represents a new paradigm where you can just like very easily report everything, but then querying it becomes a challenge because it's all in whatever format it came in at, right? And you don't really get any of those benefits of being able to read it really, really quickly. And then we have the newest architecture paradigm, which is called the data lakehouse. So really the main difference between a data lakehouse and a data lake is you're basically taking your data lake and you're applying schema to it. And that's where Iceberg comes in. So Iceberg is a catalog. And Parquet is a format, a file format, right? So you would have a bunch of Parquet files. Those are the files that actually contain your data. And those would live on S3, right? And they've just got blobs and blobs of data in them. Parquet is a columnar format. So each file is going to have some columns across a certain subset of rows, depending on your partitioning schema and things like that. But knowing how to query those files, right, becomes challenging. If you have petabytes and petabytes of these files, you would have to read all of them in order to respond to a query. And so what Iceberg does is it creates a catalog or an index of what is inside those files so that you can, before you read the files, know which ones are going to contain the data that you're looking for. And then you can read them really, really quickly. A warehouse is like structured database. A data lake is big unstructured data set of everything. And then a data lakehouse is like applying structure to the big unstructured lake.
Yeah, but essentially with the data lake and the data lakehouse, you didn't have to have that structure to begin with. So it's easier because you can just put your data there and then figure it out kind of post hoc kind of thing.
To an extent, right.
Yeah.
Yes, you can post hoc sort of work with the formats and load them into catalogs as long as there's some consistency.
Okay, yeah, really interesting. All right. And then have you ever, kind of going back to, I think you said you did product management stuff before, and obviously you have a lot of experience in the observability space. Have you ever personally dealt with a really difficult production outage, or do you have any tips about proactive and reactive observability in these cases?
Ooh, yes.
You don't have to say the name if you signed an NDA.
Yeah, no, I mean, I've been on calls with like way too many people on them in virtual war rooms, right? Because most of my career was remote. Um, and sometimes it can be something really, really silly, like the way that a certain file system behaves. Um, no, observability is really challenging. It's challenging to know what ways in which things will break. And I think having humility and just sort of, I think more often than not, so there's the tooling challenge, right? And I would say proactively, right, make sure that you're instrumenting as much as you can, make sure that you have good structured logs that are easy to sort through, that you're using logging levels appropriately at the very least, if you're not doing distributed tracing, right? Make sure you have metrics that tell you when things are broken before your customers tell you. Make sure that you have basic alerting in place. But once you have all of that stuff, after that, it's really more often a people problem than a
Mm,
technology problem. And it's just about making sure that the people with the right knowledge are able to share it at the right time. That's
interesting.
really the challenge.
It's an interesting way to cover it, and I can imagine, yeah, with the stress involved, that it's not only making sure, like you said, instrument as much as possible, technically be prepared, and then, but also, how do you manage stress and how do you keep people motivated if maybe they're unhappy and make sure the right people are where they need to be? That's interesting. It's a bit of both. So
Yeah.
it requires good
And you can
management
you
and good
can
tech skills.
you can even proactively start to work on that with the tech, right? Like with how you instrument things, if you're intelligent about uh basically using assigning ownership in your metadata of your instrumentation, so that you know which team owns which telemetry, not just what services, right?
Interesting. So yeah, basically proactive monitoring isn't necessarily just about getting the thing set up. It's making sure everyone on your team is trained, and like you said, assigning, I think, the metadata too. So it's a bit of both. Yeah, people are prepared and the tech is prepared for when things go wrong.
Yeah.
So obviously you have a lot of experience in the observability industry. What would you say are some opportunities? So things that you're excited about, either at your company or in general, and what are some challenges, places where you see developers continually have problems, or like maybe we're missing a tool, to give like kind of a broad analysis.
Oof, oof. Okay. It's hard to talk about opportunities without mentioning MCPs right now. And I know it's a buzzword and I'm loath to invoke it, but it is sort of this holy grail that people have been talking about for almost a decade or longer at this point, of kind of AIOps, and the idea that you could just talk to a chat interface in order to debug a complex system. So I don't think we're quite there yet, right? Like, I certainly don't think that you want to let LLMs loose with privileged access to your servers right now. We're not at that point, but we are at a really interesting point for using those LLMs and those chat interfaces as a search tool and as a tool for very, very quickly comparing and analyzing huge amounts of data, much, much more data than a human can. And we've been talking about the huge amounts of data generated by observability. So I think that's really interesting, right? And I was having a conversation with someone from another company, and I was kind of sharing my vision for the future of observability UIs and how it should be focused on navigating around resources and entities, and I was very much describing a click and point UI, and she said to me, "Well, what about chat?" And it just sort of like broke my brain, because I'm like, oh, none of this will matter, right? We'll just ask the AI what service, what's the SLA, or what's the status of this SLO, or what SLOs are being violated right now, and that can just be immediately brought to our attention. But that stuff is really fraught also still, right? Like, it's not perfect, and people in observability, I find, like to have a lot of control over everything, and like to have sort of certainty that things are behaving, that things mean specific things, right? Um,
I used to work with just to touch on like that buzzword
Yeah,
part, older
yeah,
older engineers, and I feel like there's always one of two responses. You get someone who's like full on like, AI is here, it's going to revolutionize everything, and then people that are like, oh, the AI winter has been here and it'll come before, and we have to worry about singularity. And I'm talking about very broad sci-fi terms, and we're talking about a specific LLM tool in this case, but it's interesting to sometimes stop and say, oh, wow, like how we use this specific tool could be entirely different in 20 years. So it's a good balance to straight. Like, hey, like we don't know if the tech is here yet, but when it gets here, it could really change everything, and that could be exciting. So that's an interesting thing that might, like you said, totally revolutionize what the UI of an observability tool looks like, even if SREs right now want a lot of control.
yeah, absolutely. And then in terms of challenge, you asked about challenges, right? To me, it's I would have said adoption, although I'm starting to hear more and more, and maybe it's just the spaces that I tend to inhabit. Um, right, but it still feels like there's a lack of maturity at a lot of organizations and a lack of understanding around observability. It's not very attractive, right? It's not attractive to be the person that fixes observability at your company, and especially if you do a really, really good job, you're very, very likely to not be appreciated.
Oh,
Um,
right. It's that thing is like if they can't see the problem because you're doing such a good, oh yeah, that would be really
yeah,
stressful. And you're like, I am doing so much work.
yeah.
Yeah.
So there's a special kind of person that likes to obsess over observability, and it's not every engineer, which I completely understand. But yeah, I think that leads to sort of a lack of maturity in practices and people sort of just lobbing logs into a system without really understanding why or how they might use those, and spending a lot of money in some cases or not having the data that they need in other cases. I think those are the biggest challenges.
I've heard that's a huge barrier. And I think that's why the open source tools that we work with are so important, like whether it's what Altinity does to support organizations that want to use Clickhouse in their observability setup, or in other ways with data, or in terms of Coroot being something accessible and open source people can use. When it comes to observability, there's a lot of big vendors in this space, and not everyone can afford them. And if you have to go to your, whoever does the sign off on the SaaS and say, this is what we need for our system, maybe if they're a non-technical person, maybe they're the vice president of operations or something, they're not going to understand. They're going to see the cost, and they're going to go, we don't want this. And it's going to be a tough job to be the engineer that convinces them, no, you do need this, so that, there's not a huge outage that prevents clients from getting to use the software, right? So it's hard. It's definitely a difficult position. You are familiar with Coroot, obviously, and if you could share a little bit what your thoughts were about it and anything that stood out to you about using Coroot.
Yeah, so one of my favorite things about Coroot is that you just turn it on and you get sort of instant observability without doing any extra work. Which for me, for a lot of the things that I'm doing, especially as a developer advocate, I'm working with short-lived sort of ephemeral environments and demos and things like that. And so having an observability tool that I don't need to carefully craft and tune and plug into my application and into my system is extremely valuable, that I can kind of just go in, turn it on, and see everything. And then I'm also working with a lot of other observability tools. So observability for observability is a very tricky challenge, right? But with Coroot's eBPF capabilities, I'm able to really, without doing any extra work, again, see what's happening with an open telemetry collector that I've deployed, and also see what's happening on the nodes, right? And so it kind of gives me a baseline that I can use to debug other observability tools that I might be trying out or building a demo around. Um, yeah, it's great that you can just kind of quickly get started and see all of that information. And then the eBPF tracing is just awesome because tracing is really, really hard. And so to be able to get tracing without any extra steps, that's just incredible.
Yeah, that's great. And it's a really interesting use case you described, because I've seen the people sometimes, especially if they're using open source, will have really large stacks. They'll have like Elastic and Loki and Kibana, all these other things. So it's interesting that Coroot is good here where you can monitor everything else going on top of your actual data.
It uses ClickHouse as the storage engine, right? So I love that, and I have a lot of ClickHouse around me, so that's very convenient.
Yeah, perfect. When something like integrates into your ecosystem. And so going back to ClickHouse, can you talk a little bit about what Altinity does and how it uses and supports people that use ClickHouse?
Yeah, what do we do to support customers with Clickhouse at Altinity? We have the best support available. Some of our customers say this, right? And what that means to us is really just supporting you from the beginning. With Clickhouse, people are dealing with a lot of data. And if you don't lay out that data correct from the beginning, you won't know it yet, but you're going to have problems down the line as you scale and as your data sizes grow. And ClickHouse, as fast as it is, as awesome as it is, it can be very, very challenging to keep everything healthy. And when it breaks, it doesn't break in sort of predictable ways. Like some databases, as your data set gets too large, it'll just slow down. ClickHouse doesn't necessarily just slow down. Sometimes it just stops working. So that can be very, very challenging. And so a huge part of what we do is just helping our customers avoid those situations. And a lot of that comes down to proactively helping them design their applications, how their applications interact with ClickHouse, how the schemas are laid out, to make sure that everything is going to be able to scale to, we have some customers who are now ingesting on the order of petabytes per hour.
Oh my God.
Which is compared to, when Altinity started 7 years ago, it's just orders of magnitude, right? Many, many orders of magnitude more than what we were seeing. And so at that scale, yes, that's something that we can help our customers with. Another big part of what we do is we run ClickHouse on Kubernetes, and we run fully open source ClickHouse. So everything that we do is totally open source, and you can take it and run it yourself. We believe very, very strongly that you should be able to just break up with us and turn off our connection and keep everything operational and not give up any features or anything like that. That also means that you can run it anywhere, right? You can provide us a Kubernetes cluster in your on-premise environment or in your cloud, and we can run a fully managed white glove ClickHouse service for you there. You can choose how much access you want to give us, whether you just want to give us access to monitoring and the control plane, or if you want to give us access to all of the data, right? So we have lots of different ways that we can work with customers depending on their specific needs and their compliance requirements. And really we can run ClickHouse anywhere. I run it on Raspberry Pis, just for experiments.
Oh, I didn't realize it could run with so little. But anyways, it's fantastic. It sounds like open source is really at the heart of the organization. Like you said, ClickHouse is 100% the open source that you use so that people have that flexibility, and whether it's on premises or on a Raspberry Pi, whatever they want to do. And it sounds like really helping them with scaling, not just, like you said, supporting them, because ClickHouse doesn't break in predictable ways. It'll be full entropy. But so not just helping when things go wrong, but also helping them set it up so things don't go wrong when they're scaling their business to enterprise levels.
Yes.
Maybe as like one last quick question, what is your favorite open source or any software project that you've worked on that you can share? And then make sure to tell us any events that you're going to be at.
Sure. Yeah, absolutely. Project that I've worked on, it wasn't open source, but I was just thinking about it the other day. I worked on a very, very early prototype of table-side ordering, way before everyone in the world was ready to use QR codes at the table side. And that was just a really fun project because it was something where we got to actually test it out with real restaurants and go and eat food and order food with our phones like 10 years before everyone else was.
Oh,
And
no
then of
way.
course,
Was
yeah,
it
of
like a
course,
QR code, or
yeah,
how
it
did
was
you?
it was
Oh,
QR
okay,
code
but
based, and
before.
we built the app, and it was tied into the restaurant's point of sale system, so you could. It was just like Uber, right? Like, so Uber existed, and people were used to this experience of Uber that you could pay and then just get right. Like you could just get out of the car and walk away. You didn't have to like do a transaction with your credit card at the end of the ride. And so it was a similar experience with our app where you could just walk into a restaurant, order your food, your credit card was on file, so you got charged automatically, and then you could just get up and leave. And the only interactions with the server would be right, like questions about the food and things to make your experience more enjoyable rather than the transactional, like, okay, this is what I need and this is how I'm paying for it.
Yeah, no, that's really exciting. Actually, that kind of loops in because I realized I also wanted to ask, like, if you had advice for like students or young SREs. But I feel like even though that wasn't open source, it loops into like the kind of beautiful part about code is if you can get your hands on something and build something that works, it's exciting. And obviously, open source helps facilitate that. That's like I think some of the beauty of software development, right? Even if it's a project where you're just helping something on like the restaurant side. So that sounds like really exciting, and I think good motivation for anyone that's maybe just learning how to code and stuff.
I think the tangibility of it made it really memorable for me, like the fact that you could hear the tickets printing in response to the app working. Just yeah, there was a certain delight to that. In terms of open source projects that I've worked on, though, I have to say OpenTelemetry, just because to me it's so amazing how cooperative the various vendors in the space are around OpenTelemetry, right? I was working at a rather large observability vendor, and most of what I know about observability, I learned from people who were working at competitive companies. And they were just open and welcoming and very willing to help me learn and grow. and to understand the space better and to really just try and make it easier for everyone, right? Like I think we've talked about how like observability is not attractive to some people, but I think that there is this shared sense of like, we really do need to make it easier for everyone. And a lot of people in the space understand that. And I really love that that's come together around OpenTelemetry and the related ecosystem.
Yeah, the idea that there's like a sense of community. It's at a when I at my previous organization we used the term co-opetition, like cooperative competition sometimes.
Yes, I
And
love
like
that
that's
term.
part of the beauty of the spirit of open source is like, okay, here's this open source tool everyone uses, and we're innovating, but we're innovating in a way that we want everyone to be able to succeed and for this to be easier. And so for there to be community and mentorship, I think that sounds like a really kind of nice part about observability that makes it a fun industry to work in.
Definitely.
So it was so much fun to interview you today. You do lots of different cool events, and I think people should go see you. So share if you've got any conferences left, anywhere that you're going to be, and then any socials where people can find you.
Sure. So the two biggest ones I have coming up will be Open Source Summit North America in Denver next week, and then also Open Source Summit in Europe in Amsterdam later in August. And I think between then and now, I'll have a few events in San Francisco that'll be small meetups hosted by Altinity. So if you're in the San Francisco area and interested in talking more about data lakes, check out altinity.com for information about those. And then, yes, I'll have a very busy fall, but not quite sure where and when yet.
It's a lot of stress traveling, but I hope you have lots of fun meeting new people. And I'll also share for anyone listening that wants to try a new open source tool, you can go to visit Coroot.com and also link our Git in the description. And it's a good way that if, say, you're spending hours on root cause analysis, those insights are just kind of there. So you can no longer eat up a lot of that time. And the eBPF will just pull things automatically instead of you have to set up instrumentation. Thanks for joining us, and I hope everyone had a nice time listening. Take care.